Cool. So good evening, good afternoon, good morning, guys. And we have folks joining from across the globe today. So officially welcome you all to the first class of the Aptos Developer Fellowship Program. Super excited, lot of energy. We have almost 80 folks joining today. So let me not waste much of the time. Let me get Sneha on the screen. Maybe Sneha. Cool, awesome. Okay, cool. There you go. So introducing our trainer, Sneha, who will be leading all the efforts for the developer fellowship program. Of course, we'll have like more and more AMA sessions from the Aptos Foundation, and also we have a couple of folks joining from the Aptos ecosystem projects as well. Who will be coming and teaching you different set of concepts. But it will be Sneha who will be leading all the efforts. So we've already shared the syllabus with you in the Notion doc. Everything you can keep following that Notion doc as the go-to document for you for the recordings for the syllabus for the assignments projects and in terms of the logistics. So let me give you a quick intro about Sneha. So Sneha is one of the true OG in Web3 space. She is also a Web3 founder at this point of time. She has been building a very interesting startup called Social 3, and which is a decentralized LinkedIn that she's creating at the moment. So the reason why we are collaborating with Sneha is she has been with Aptos for quite some time. She has taught a couple of courses and did a couple of sessions with Aptos in Tokyo before. So she is very well versed with the Aptos ecosystem per se. And before that, she was a smart contract developer. She was also a grant manager and taught at multiple companies. Like Polygon, of course, is one of that. And of course, and the most important space in the Web3 is build space. She has also taught a couple of courses there. So you guys are in very good hands. And without further ado, might be I'll let Sneha give a brief intro and then get started. Over to you, Sneha. And thanks a lot for doing this.
Hey, hi everyone. Okay, thank you for that amazing intro, Kevin. Okay, so before I get started with the class, I would love to know a little bit around what is the fundamental understanding of. Okay, this is quite slow for me. I'm not sure if it's Zoom. Uh, okay, the video is a bit slow for me.
No, we can
Okay,
hear you. Go
but
ahead. If there are any issues, I'll let you know.
perfect. Okay, so before we get started on that, I would love to know, and you folks can just react or you can type a message to get an understanding of what's the current knowledge level of all of the attendees here, so I can basically cater the course more in accordance with you folks, right? So, number one would be how many folks here own any sort of tokens? You can just react or like type a message, whatever. Okay, cool. A lot of books. Okay, nice. Okay. Uh, all right. Okay. How many of you folks have like built anything, any part of a dApp? Like it can be on the front end side. It can be like developing smart contracts. It can be any of those things. So yeah. Okay. Cool. Okay. Most of the people have. Perfect. Okay. I'm just going to present my screen. One second. Um, folks, let me know if you can see my screen.
Yes, we can see.
Just a second. Okay. Okay. So before we get into like what is Aptos and all of that, I want to talk a little bit around the okay, I can see a lot of replies on the chat as to what people are working on. That's pretty interesting. Okay, so before we get into what is Aptos, what is Aptos goal and everything, I want to talk a little bit around how did Aptos actually come into picture or the history of Aptos. So basically, like Facebook was working on this stablecoin project known as Libra under the DM blockchain. And they were like pretty adamant to build like some really really cool tech. The idea being that this stable coin will be a way that like currencies all over the world can be kind of transacted. But again, obviously, the government was not fully on board with this, and the US and the European governments expressed like some sort of issue with the same. So, what happened eventually was that Facebook had to kind of drop that project. But during this time, what did also happen was that Facebook had invested a lot of time and effort and energy into building this like this language known as Move language, which actually was derived from Rust language. So it's quite similar to Rust. And because they were the ones who were building around the problem statement, and this is like Facebook's excellent team of developers and like research folks, right? So what eventually happened was that when Facebook decided to like abandon this project, two blockchains came out of it, Aptos and Sui, which basically took this like Move language and a couple of things that they had been working on to bring this forward and build like layer one blockchains themselves, right? So for Aptos, like the Aptos founders are Mo and Avery. They again like really amazing folks, the entire team for that matter, and you can actually go and check out a couple of like their podcasts, etc. On YouTube for a very good understanding as well on how they were thinking about Aptos. But yeah, this is like more or less the short story of how the Aptos like blockchain came into picture and why it is something that you cannot ignore. Also, like bringing one more because I'm a founder, bringing this fact on board as well that Aptos was able to raise, I think, 350 or 300 million dollars, and in the first round they brought in A16Z. So this is a team that knows what they are doing, and they have been able to ship some amazing technology, which we're going to talk about right now, and how the idea of what a blockchain is, what we have been doing around in terms of the Ethereum ecosystem, the Solana ecosystem, and how they kind of have developed over that idea to actually come to a better or more like a actual mass adoption like blockchain. So yeah, let's dive a little bit deep into this. Okay. So into Aptos, delivering a scalable, safe, and reliable blockchain. Okay. So we will be talking about each of these points one by one. The first point being the scalability aspect of a blockchain. So currently, if we look at the like different options that we have Bitcoin, Ethereum, and Solana. So like you know like for Ethereum we can think about 10 to 12 TPS. For Solana, okay, we have 50,000 TPS, and there are like a couple of other blockchains that are doing like different throughputs. But while we're still thinking about this problem, I want you to understand that this is not actually at par with what it might be required to build something that is compared to like a Web2 application like YouTube or something, right? That is like processing like millions of transactions, right? So how can we think of a system that can actually build scalability in a manner that a lot of people can actually adopt in terms of blockchain while maintaining our dilemma, right? So okay, and then we are talking about safe and reliable blockchain. So this again coming back to all of the DAO hack and everything that has happened, right? While we are working towards a lot more safety in this field, there is a reason that these attacks and the hacks are like they keep on happening. And while yeah, you might credit like okay, it's basically the smart contract and they are the developers, they are not writing the functions well and right all of these things, but Okay. Am I audible, folks?
Yeah, we can hear you.
Yeah, we can hear you.
Okay, someone just wrote a comment, so I asked. Okay, cool. Uh, okay, so while we want to credit, like we don't want to like talk about developers making mistakes in the smart contracts and that being the reason of all of these things happening, because it should not be the responsibility of a developer to think very thoroughly when we are talking about writing smart contract code. There's a reason that there are so many vulnerabilities, especially with solitary code. It's just because of the design of the language itself. So we need to move away from these convictions. We want to create something or move to a language that can, by its design, prevent these sort of problems or attacks or hacks or whatever, and should not be basically the responsibility of the programmer, right? So this is what we are talking about. Um, Okay, so yeah, as I mentioned, so for this, we are relying on this new smart contract language known as Move, which is a safer language than the current mostly used smart contract language in the EVM ecosystem, which is Solidity. And we will like talk a little bit around why that is the case. Okay, come on back here. But before that, I want to talk a little bit around basically three things primarily. Number one is from the scalability point of view. I want to talk about the Aptos consensus mechanism, which is known as Aptos BFT. Number two is what I is basically the Aptos parallel execution system, the Aptos block STM, and how it is different again compared to whatever different systems that we have currently in place for Ethereum, Solana. And then I want to touch a little bit upon Move and then also what we'll be covering on Move. Okay. So first of all, starting with the Aptos consensus mechanism, Aptos BFT. Uh, I want to talk a little bit before this on BFT. So can you folks, can anyone basically speak a little bit around what is BFT? Anyone? Uh,
So it's
okay.
like uh
Yeah,
so
go ahead.
bilateral software means like in a distributed system setting, uh, a distributed system will be called bilateral software if uh, some part of the distributed network are acting malicious. So that's what I mean.
Tahlil, I'm not able to hear you well.
Oh, sorry. So bilateral software means that in a distributed system, uh, uh,
Sorry, a
in
lot of
distributed.
echo is there, Tahil. We
Oh,
can't
sorry.
hear you.
So maybe the connection is a bit slow. Uh, the state of in a distributed system would be called bilateral software if uh, some actors in the distributed system are acting maliciously and the system would still withstand that the malicious behavior of the malicious actors.
Tahlil, I'm really not able to hear you. Do you want to type it out on the chat? Does anyone else want to talk about what is BFT? So this Byzantine fault tolerance is the correct like this thing, but what does it mean? Does anyone want to talk about it?
So
There's some folks
basically,
who are, yeah. Go ahead, Omkar.
is a consensus mechanism that is used in the blockchain to ensure that all the nodes in the network agrees on the state of the blockchain, even if some of the nodes fails or malicious. So BFT can uh, work in that.
Perfect, perfect. Okay, awesome. So I have here Vaithishwaran who has also given an example here. So let's talk about this example. So instead of nodes, there are a couple of people who do not have the base idea of this. So let's try to build it as a story. So how this actual term also came into picture. So Byzantine is basically like some people who were involved, like who were doing wars and all, and they by definition were like considered to be people who are kind of malicious or treacherous, okay, in war. So they were not trusted. Like this is like a history thing, okay. So imagine that we have a couple of war generals, okay, and here let's, for the sake of this four example, we can imagine that we have four generals here, out of which one of them is not like is basically a traitor, right? We cannot trust this person. So what is going to happen is that we have basically our kingdom or whatever, our king is basically saying that okay, we are at this point and we are all in our different camps. All of the generals are in different camps, and they are supposed to fight against a certain country or whatever, right? So now like they might get some sort of like a command which can be attack or retreat. Okay, you decide to whether you should be attacking, or if you feel like okay, we possibly might not win, so let's just retreat back. So imagine a system like this, and we have this one general who cannot be trusted. So while all of the other generals are giving this command of, let's say, attack, because that's the command that has been given, this general, in an effort to try to trick the system, will give the command retreat. Okay, so what is going to happen in the system is that these generals, because they are in different different camps, this is basically building on to the decentralization aspect of things, right? They're in different camps, they cannot communicate or they don't get the information at one centralized place. So they are supposed to share this information with each other. So now what will happen is that this let's assume every general is connected to each like every general basically. So for every, just do like a normal permutation and combination, if there are four people here, so one person will receive three messages. Okay, so every loyal general here will receive three messages. One of them would be retreat, which is coming from the traitor, and two of those messages would be attack, that you know what, we should go and attack. So this would be the case. And how are you supposed to decide, okay, what is to be done? This is where the consensus mechanism comes into place, that okay, let's just take the majority of the vote here. So in this case, because there is only one fake person, right, one traitor, you will still decide to attack, because 2/1, right? So you will still decide to attack. And here we are able to maintain the BFT thing, right? Because we are able to tolerate having that one general that is like basically a traitor. Now imagine if we change the equation a little bit. Now imagine we have four generals again, but instead of one general that is trying to like trick, there are two generals who are trying to trick. So now every loyal general will receive one message of attack and two of retreat. And what will end up happening is that now the majority will move in the favor of the traitors, and they will basically retreat back. So now here the tolerance is not able to be maintained. So this BFT mechanism is basically the consensus that is the base for all proof of stake, like whatever consensus we see. This is basically the basis for that. And this means that in any equation, at least like basically you need to have less than 1/3 of whatever total nodes can be like traitors. Okay, if it is more than that, the system will collapse. Okay, so this is more or less the idea of BFT. uh, okay, is this definition okay? Can I just get like a reaction that okay, whatever I said made sense or did not make sense, or there any more questions around this? Now, and what you can also do by mentally is also basically that now we did like a 4 general system. You can try extending it to 5, 6, and like try to do the like whatever math would be, that okay, if this is one, then these are the message that is coming. This is this, then these are the messages that are coming. That will help you come to the same conclusion as 1/3. So basically, you can okay. Uh, Okay, I do have a couple of messages around not being able to understand. Okay, let me just try to repeat the same thing. Okay, is this related to 51% attack? Yes, this is related to 51% attack. But that being said, 51% attack makes more sense for Bitcoin. When we are talking about BFT, we have tolerance only up to 33%. So if more than 33% of the chain is in a weird position, like basically owned by someone or blah blah blah, then it will collapse. Uh, what's the difference from other consensus mechanism? Yeah, this is just the basis for the proof of stake. If you go to the proof of work, okay, do you folks want me to talk a little bit around the proof of work consensus first? Would that be helpful? No. Okay. Uh, okay. There is some mixed opinions here. Um, is it something like max people voting for something will happen or will be able to restore the position? Yes, it is like that. It is the majority that we are defining, and what we're trying to arrive is at the maximum tolerance that can be like set to enable something like this. Otherwise, the system will collapse. So okay, going a little bit back to the Bitcoin stuff. So in Bitcoin, we have this proof of work mechanism consensus, which talks about solving a very, very difficult cryptographic puzzle. And that is basically the meaning. That's the work that someone has to do to then be able to like get rewards and for that block to be added. Okay, this is basically how a block is added in Bitcoin. It is based on proof of work, but in proof of stake we have validators, and then that majority of thing that I'm talking about comes into play. So for Bitcoin, the 51% attack is correct because the consensus mechanism is proof of work. And there, when you're talking about the chain, and if you want to again maliciously enter a block, that means you need to own more than 50% of like Bitcoin, or like have that much compute power, which is economically not feasible for you to own that much. So it is not a possibility at all. Now, for proof of stake, the security is not as harsh as Bitcoin. We are coming to 33% because now we have replaced this minor concept with the validators concept. And now we're talking about the BFT, the Byzantine fault tolerance. So Byzantine fault tolerance, again, I'll reiterate once more, talks about um, whenever we have like whatever number of nodes, we have to ensure that less than 33% of these nodes have any sort of malicious intent. Otherwise, that can basically collapse the system. There is a very good article on this. Yes. Oh, I do not know Pranshu is here. Okay, cool. So when that collapses, then basically you cannot like manage the system. Cool. There is a very good article on Ethereum's website on every possibility that happens. So I will also maybe share that post this session with you folks. Okay, perfect. So now we spoke a little bit around what is BFT. I want to talk about practical BFT, PBFT. Okay, so PBFT basically came into picture with this idea that okay, when you're trying to establish, I'll just show you here. Okay, uh, okay. So what we are trying to do when we are doing all of this BFT sort of this thing is that we end up communicating with all of the nodes. So there are a lot of messages being exchanged, right? Because I spoke like if we have four generals here, every general is receiving at least like three messages in like one round, right? And this is like going on and on. So this is basically the structure that you can see here. But this means that this is painfully slow to carry out in terms of consensus, right? So we want to move away from this to having this sort of a communication where we are electing a leader to basically come in, and only that person needs to be like communicated back whatever is the like so for example, if I am one of the generals, then instead of communicating to all of the generals, let's say I have the command retreat, I will say retreat. I just need to say retreat only to the leader. That's it. So this is like a couple of developments over the normal BFT that was made to make this process like less slow. Okay. And then they also have the introduction of a pacemaker, which does not allow for the same validator to be selected as a leader twice in a row, triggering like a new leader election. That's the thing. So this is not centralized. Like every validator has its own reputation. So based on how they are behaving, based on the amount of tokens they have staked, that will be changing, and it's not fixed. So because of this pacemaker, like it's like get like it's there is leader rotation. So in like two consecutive rounds, you won't have the same leader. So it is not a centralized this thing that okay, this is the leader and it's decided and it won't change ever. So that is not the case. Okay. Uh, so this okay. So this was one of the first starting points to basically make Aptos more scalable, starting with basically the Aptos BFT consensus mechanism. The second thing that we started working on was along the lines, like they started working on was along the lines of the Aptos block STM. Okay, and this is I think a very interesting thing that I will like try to explain to the best of my capabilities. Um, okay, right. In terms of okay, Ramdat, your question on how next leader is being picked, there is a mixture of a couple of different factors here, including them having like a completely randomized like a BRF thing as well for like leader election. I will check like basically a randomized function. I will share about that, but it also has a couple of more factors into play. It's not very straightforward, as I said, like token stake, not selecting the same leader, but a couple of more variations on top of that as well, and reputation based on how long you have been active, what all things you have been doing, if you're picking up the transactions correctly and all of that. So it will be based on a lot of these factors. Okay, so okay, Aptos block STM parallel execution. So this I will try to first set like a stage on how we can imagine transactions happening currently. Okay, so whenever we have different transactions come in, okay, so all of the like unconfirmed transactions, they basically go to a mempool. Okay, so think like we have this space and there are a lot of unconfirmed transactions here. Okay, and now, if you're talking about Ethereum, we have sequential execution. Okay, so what will happen is that all of these transactions will come, they will execute one after another, one after another. Okay, so you can imagine that this process is going to be very slow, right? But then you might question that why are they doing it this way? Like, why can't they just maybe parallelize the system and like do it parallelly, right? Why do we just need to run it one after the other? So this is where I want to take you back to one of the initial problems of like when we came up with blockchain. So blockchain's first initial concept was how can we create digital currency, right? Like not digital credit, but actually digital cash. And with that came a very huge problem, right? So we had like think of like a couple of initial protocols that actually came up with it without introducing the blockchain concept. Was that okay? I have, let's say, $100. I have $100, and I basically want to, let's say, I want to buy some chocolates, and I want to buy pizza. Okay, so I go to a store and I buy, I give them $100 and I get chocolates. Now, if it's actual cash, then I don't have $100 anymore. I just gave it to that person, right? And when I go to the next place, I cannot actually give them anything because I don't have anything to give in the first place, right? So sounds perfect, right? It is how it's supposed to be. At 100, now my balance is 1 second. Okay, I had 100. Now my balance is zero, right? But if you're talking about a concept like invisible this thing, right? Invisible cash in some sense, digital cash, invisible cash, right? So here what can end up happening is that I have 100 and I give it to buy chocolates. And now, yes, yeah, Rishikesh is on point. And now, because it's invisible, and let's say these merchants are not communicating with each other, there is no record that I have spent this $100. What I can end up doing is I can spend this 100 invisible bucks again and get some pizza. And this is the classic double spend problem. Correct. So, in order to avoid this double spend problem, is how Bitcoin came into picture. We had a ledger, we had like transactions recorded. Now I'll come back to why am I talking about all of these things and what's the context that I'm building here. Okay, so now we have this system where we're talking about sequential execution of transactions. Sounds good. But again, here what might, if we try to parallelize this operation, what might end up happening is that, let's say the same example, I'm buying chocolates and I'm buying pizza. So there are two transactions, and let's say I have 100 as my balance. Okay, if I have two different channels for the parallelized execution, so I can just run both of these transactions simultaneously and both of them will go through. But that should not be the case. But if I think about it from a sequential standpoint, so after running the first transaction where I spent 100, my balance will be updated in this ledger as 0, which means the next transaction would not go through. It will give me something like insufficient balance. Correct? That's why this parallel execution thing won't work. But that is when Solana made it work. How did Solana make it work? How can we work around this parallel execution problem? So Solana was able to make it work because they came up with this again with this interesting concept of just going through with like the independent transactions. Okay, so I will talk a little bit about what independent transactions means in this context. Okay, so now I'm just assuming that it's me and I'm buying this, right? Now imagine the first transaction that I am buying chocolates of $100, and let's say Omkar here is buying pizza for $100. Now these two transactions, they are independent in nature, right? Because they are not trying to change the state of a same account, which was happening in this case, which was why one after the other it needed to be like run. Otherwise, parallel execution would mean double spending. So first of all, we need to identify what are the independent transactions in this case. And these are the transactions that can be ordered in a way that they can be run across parallel systems, parallel execution. But the transactions that are dependent in nature, they should be run in a sequential manner. Okay, so this is more or less how that basis formed for Solana. I'll just take a little like minute right now and pause and just want to know if like things are clear up to this point. I am very like cool with explaining things again and typing it out as well if that makes more sense as well to the participants. Okay, I'll just also write it here because okay Pranav, let me actually write and also explain. Okay, so I'm just gonna say Sneha, my balance is 100. Okay, and this is gonna be chocolate vendor, pizza vendor. Okay, so I'm gonna say transaction 1 tx1, which says Sneha gives $100 to chocolate vendor, and transaction 2 tx2 is gonna be Sneha giving $100 to pizza vendor. I'm just gonna send the message now. So just give me a second. Okay, so this is our basis. Okay. Now, what does sequential transaction means? Transaction means that okay, and also for the next time, I'm actually gonna get like my tab or something and write it there, because I understand that I'm writing it here because I got my slides and stuff. So yeah, next time I'll just like do something like I can write on a board and share it with you or something. But my handwriting is like very awful, so I'm not sure if you folks will understand. Okay, sequential transaction is gonna look like we run px1, balance Sneha will be 0, chocolate vendor will be 100, and transaction 2, balance Sneha is still 0. So this is gonna be like cross because I cannot run the second transaction. Okay, so this is what happened in a sequential transaction, one after the other. Px1, then we go to Px2. This is a sequential transaction. Now, what happens in a parallel execution is Px1, Px1 and Px2 are run simultaneously. Okay. Oh my god, I do not know how to spell this. Okay. So transaction 1, we have gonna okay, balance is gonna be Sneha 0, chocolate vendor is gonna have 100, transaction 2, balance Sneha 0, and pizza vendor is also gonna have 100, which does not add up because obviously out of my $100 we have somehow produced $200, right? Okay, is this clear till this point? Okay, perfect. Now let's do an independent transaction. Okay. Independent transaction would be px1 will keep the same, Sneha and chocolate guy. Omka, what do you like? Where are you gonna spend your $100? Omkar is not saying anything, so I'm just gonna assume that he's gonna spend his $100 on pizza. Okay, so independent transaction. Transaction 1 is Sneha with the chocolate vendor and Omkar with the pizza vendor. Okay, you also want to buy chocolates, is it? No, then it won't be an independent transaction anymore. We can't do it. You have to say something else. Okay. Okay. Can you give me a minute, folks? I'm just gonna get some water. Okay. So independent transaction, transaction 1, Sneha and chocolate, transaction 2, Omkar and bag. So this is gonna be px1 will result with balance Sneha 0 and chocolate vendor 100, and px2 is gonna be balance Sneha balance Omkar 0, assuming Omkar had $100 to begin with. I have not mentioned it, so yeah, just assume that. Bag vendor will have 100. So since these two transactions don't have anyone common here, right? So we are not updating the state of like one same account here. These two transactions can be run simultaneously. It would not be a problem to do that. But instead of this, if we assume that Onkar is also getting chocolate, then it's a problem, because then if these transactions are run simultaneously, the balance of the chocolate vendor would not be updated correctly, right? So this is the reason why and how we are basically classifying what is an independent transaction. Is it clear up to this point? Okay. Okay. Perfect. Okay. So now what did Solana do in this whole equation? So what Solana did was independent transactions will be run simultaneously, and dependent transactions, like my example of buying chocolate and pizza, would be run sequentially. So if I have to draw this as a system, it's how I don't know how to draw this in this, but okay. Channel 1, let's say PX1, PX2, PX3, and PX4. These are 4 transactions. So let's say PX1, let's say PX3 and PX4 are dependent, and the rest are independent. And assume that like we are drawing just like 2 channels for execution. So PX1 will go through channel 1, PX2 will go through channel 2, and then PX3 and PX4 will have to go again through channel 1. Okay. PX1, 2. So since TX3 and TX4 are dependent, TX1 and TX2 could run perfectly. And then these two transactions are dependent, which means that they have to be run in a sequential manner. Does this make sense? Okay, perfect. So now we have an understanding of what Solana is doing. So, but what is a requirement here? So there is a base requirement here. What is that requirement? It's that we need to know what states are being updated. Does anyone want to like answer this? Like, what is the base requirement here to make this function, make this happen? Alice is saying the nature of the transaction. Does anyone want to like timestamp? So what is the information that we need here is basically if we have to classify that these are independent and these are dependent transactions, then we need to know what states are getting updated. So essentially we need the state dependencies beforehand. We need to know that okay, this is going to be a dependent transaction because these both transactions are trying to update the same account or something. So we need to know these state dependencies beforehand before we can start with the execution system. Yes. Yeah, you can say all of these things. Basically just like a state dependency that we need to know beforehand. Okay, so now that we have established this, I want to come back to how is Aptos differentiating here. Okay, So Solana was able to scale to 50,000 transactions per second, which is pretty good. Aptos claims to have a transaction speed of 160,000, 130,000 to 160,000 transactions per second. And I would say block STM is like one of the major reasons for making that possible. And we'll talk about how. So now, as I said, like one of the main blockers here is going to be knowing these state variables beforehand. Now, Aptos actually is trying to solve for it in the form of being optimistic. So what I mean by this is that here, instead of knowing the state dependencies beforehand, what Aptos is going to assume by its nature is that all of these transactions are independent. Okay, so what does this mean again? Like this is, and the truth being that not all of these transactions are going to be independent. So what do we do when there's like dependent transactions coming in? How is Aptos going to handle that situation? Right? So we will again try to take the same example that we did and try to answer from that perspective. Okay, so I'm just gonna copy this. Uh, uh, okay, same example, 4 transactions. PX3 and PX4 are dependent. We have 2 channels. Okay, so now assuming that this was, let's actually make this 4 channels. Assuming that this is okay, I am actually gonna I'm gonna change this prompt a little bit so that the example becomes a bit better. Okay, so this is the new prompt that we have. We have 4 transactions, TX1, TX2, TX3. They are dependent in nature, and TX4 is independent. So that means that TX1, TX2, and TX3 must have like a common account where they are making certain changes. So if I have to extend back to my same example, I want to buy chocolates, I want to buy pizza, and maybe I want some nice shoes for myself. Okay, so some like very cool sneakers or something. Okay, so again, my balance is the one that is going to get updated in all of these things. Now let's say that instead of just having $100, now I've been gifted with $1,000. Okay, so assuming that I have $1,000, Aptos maintains a versioned data structure for your account details. Okay, uh, basically my token balance. So what this means is that I'm gonna say balance. So think of this as a table. Think of this as a version table. Okay, I'm gonna explain how this will look like in a second. Have balance. So original balance is going to be 1,000. Okay. Now, what is going to happen here is, let's say transaction 1 is my transaction with the chocolate person, and I'm going to buy chocolates because now I'm rich. So I'm going to buy chocolates of like $200 maybe. And transaction 2 is going to be me buying pizza for maybe $500. And transaction 3 can be me getting some stickers or something for $300. Okay, so now this is what we are gonna think that okay, these are like the prices or whatever. Now assuming that we are gonna forget for a second that all of like TX1, TX2, TX3 are dependent, because Aptos optimistically assumes that all of these transactions are independent in nature. Okay, so that means that TX1, TX2, and TX3 are all going to run simultaneously. And here is when the version table comes into play, and I will show you how. So we have this balance Sneha original, which is 1,000. TX1 dash is going to represent what is going to be my balance after doing transaction 1, which would be 800. 1,000 minus 200, 800. TX2 dash is going to be my balance after running transaction 2. But here is a mistake that a lot of people will make, which is that now you will subtract from 800. Like you're like, okay, 1000, and then she got chocolate. So now she has 800 left. Now we're gonna buy pizza, right? So 800 minus 500 should give me 300, right? But no, why not? Because we are running these transactions simultaneously, which means that I have to consider the original value. I am not going to consider the modified value that would have happened in a sequential thing, right? Sorry, does anyone have any questions? Okay, cool. So transaction 2 is going to be, instead of 800 minus 200, it's going to be 800 minus, sorry, instead of 800 minus 500, it's going to be 1000 minus 500, which is going to give me 500. And TX3 dash is going to be 1000 minus 300, and not whatever, like 300 minus 300. It's going to be 1000 minus 300. So it's going to be 700. So I'm just going to send this first. I want you folks to take a look and ask any questions that you might have right now, because I feel like this is like this is gonna start making a bit might be a bit complicated from this point forward. So does this make sense? Here I'm also gonna draw this, maybe this will help. So TX1 is going through channel 1, TX2 is going through channel, I think I did write that. Yeah. Yeah, this is assuming that TX1 is going through channel 1, TX2 is going through channel 2, TX3 is going through channel 3, and TX4 is going through channel 4. Okay, any questions? You can also unmute and ask if there are any questions, or if things are not clear. I'll wait for a minute. And also reiterating on this point, is this example? Yes, this is an example of parallel transactions. We are assuming that all of these transactions are independent in nature, and hence they can be run simultaneously. And because we are assuming that, we are always calculating the balance from the original and not the modified version, because that transaction hasn't taken place. We have these 3 channels and it's going simultaneously. So for all of them, for them, the state is currently 1000, right? Because the TX1 has not processed and then TX2 has started. It's all going simultaneously. So for all of them, the state is that balance is 1000. Okay, perfect. Okay, so integrity is violated here. What do you mean by that, Krishnendu? Not exactly sure if I understand. Okay, in the meantime, I'll just explain a little bit more on the same. So all of these transactions being run simultaneously does not mean that these transactions have been actually committed. So they are not committed. We are just putting this in this small version table of ours. We are not actually committing it. Then it would be like a whole challenge. So this is just for us to actually now work on correcting this, and I'll come to that in a little bit. I'm just gonna check. Okay, yeah, I think I understood what Krishnendu had in mind. Okay, these are not actually being run and then we are moving back. No, this is just like a state before committing that we are just. Yes. Okay. Cool. So now we have this version table. I am just gonna copy paste this from up. Okay. Cool. So balance, Sneha, original is 1000. These are the 3 transactions. Now what will happen? Now we have done all of this, like just being very optimistic about life, and we have run all of these transactions. But now we are realizing that, okay, we need to move this through a verification process to actually like basically hold a power assumption that yeah, these are all independent transactions. So the way that we will be doing that is we're going to compare the state of and that's the reason we are maintaining this version database as well. We're going to compare the state during like before processing and after processing for all of the different like mentioned here, right? So let's go one by one. So it will like think of every transaction one by one. Okay, so we have our for this table, not for the entirety, then it's like a complete sequential order that you're thinking, just for this table. So this table has a couple of different entries. So what we will do is, okay, transaction one. So while we were processing transaction one, the original balance was 1,000. Okay, and then like basically we process this, and then we did like, okay, 1,000 1,000 minus 200, right? 1,000 minus 200 is 800. Okay. Then we move to the next transaction, which is TX2. Here like before the processing of the state, we assume that like basically we just saw the original balance value, which is 1,000, correct? But now what we're gonna compare this 1,000 with is the latest version of the database, like this table, up at that point, which is going to be TX1. So what I'm trying to say is that at the point of TX2, what's going to be the latest version? It's going to be TX1 in this table. TX1 at the time of TX2, TX1 dash is going to be the latest version of the updated balance, right? Which is 800. But before processing, the value that we calculated was 1,000. So there is a mismatch between both. So at that point of time, TX2 will fail, and that would be maintained. Now I'll again try to explain this a bit further. Okay. And I want you to forget about TX3 for this moment because it might get a bit confusing otherwise. Okay. So I'm just gonna write maybe like a small note here. Okay. So TX1 before processing state was balance is 100 original, and latest version is also original. That is, you look up in the table. What's the latest version just before this? Is also 1,000. So correct. Now, if I do a comparison of TX1, the TX2 before processing, again we assume that the balance is 1,000. Okay, I have incorrectly in the previous message written balance is 100, but consider that as 1,000. But the latest version in this case won't be original. It would be TX1 dash, for which the balance is 800. So there's a mismatch in this case, and this will fail. Can you take a look, folks, and see if this makes sense? So at every point from this version DB, small table, we are just looking upwards to the last or the latest state, comparing it with the processing state. Essentially, this is the logic that we are using to find if the double spend is happening. Because if there's a mismatch in both of these states, then you know for sure that, okay, some issue has happened here and it was not supposed to be this way. And that's why our assumption of like thinking that all of these is going to be like independent transactions is not accurate. We have dependent transactions and this will fail. I'll take a moment here and ask if this makes sense. Okay, cool. Uh, so now we have this mismatch state because the latest version and the version before processing not matching. So now our table, which we were maintaining, I'll just copy paste that table again from up. Okay. So now what will happen is that instead of this 500 entry, we can just mark it as failed over here. Okay. So because this state has failed, this would mean that before this particular transaction is resolved, the newer transactions that will come with for the same, like, changes in the same this thing, that would not go through unless this particular thing has been resolved. So by this verification process, what we are actually ending up doing is all the transactions, like once this transaction is failed, automatically assume that all of the transactions that are going to happen on this will fail because this one has not been resolved, and retry this one after the other. So we are now making it do the Solana thing, but in this manner. Rather than knowing all of the state dependencies beforehand, we are optimistically assuming that, hey, maybe all of them are independent. Let's just make them go through all of these different channels simultaneously. Right? This is our base assumption. And if that assumption is wrong, if there are a couple of dependent transactions in this, what will happen is we'll have this version structure, we'll maintain, write the versions, we'll do the verification process. If the verification process is not going through, fail, maintain that fail thing for whatever transaction it failed at, and wait for it to get resolved, and then all of the other transactions will follow sequentially for that. This is the way that we are differentiating from this thing, Solana's thing. And while in this process, one another thing that we are doing, which is good, is that we do not need to know the state dependencies beforehand. Now there might be this question, okay, and it would be a very valid and a very good question, that what is the point of doing this? Why are we optimistically assuming that, yeah, Suleika is asking how it's going to be fast. Why are we optimistically assuming that all of these transactions are correct, and then we are doing all of this process? So does anyone want to take a shot at why are we doing this? What might be the reasoning behind? You feel free to like unmute and share or write on the chat around this.
Just a doubt. This is something we are implementing in Aptos, or it is something in Solana from before?
Solana needs to know the state dependencies beforehand. So it will classify the independent and the dependent transactions. It will run the independent transactions simultaneously. It will run the dependent transactions one after the other. Here in Aptos, we do not need to know that. We are going to assume that all of the transactions are independent and all of them will be run simultaneously. In case we run into problems, is when we do the verification and all of those transactions get processed again. Yeah, okay. Okay. Yes, definitely. We do not know the state dependency, so we are saving up time there. Swapna is saying if they're independent, actually the process would be fast to increase the number of transactions in certain period of time. Okay, yeah. More or less, this is the case that all of you folks have answered. Just like shedding like one more this thing, just because we all are like studying computer science and all, and mathematics, computer science, for any problems that we are getting, we always talk about things in the perspective of what's going to be the best time, what's going to be the worst time, what's going to be the average time for doing anything, right? And that is a very interesting thing to think about, on why, not just this, not even talking about just this problem. If you actually try looking at problems in your life and thinking about it from an algorithmic standpoint, you will find yourself applying this thing in like a lot of different problems, like optimistically assuming. A lot of people say things like, like someone would say, if you're supposed to make a decision, they're gonna say that, hey, but what if this happens? What if this negative XYZ circumstance happens? And then they will say that when that happens, we will see. We will deal with it at that time. And we will just go forward with it. That's the optimistic approach that we usually apply to our decision making as well. The reason being that if it's the best case, what is the best case in this case? Assume that actually all of the transactions were independent in nature. So all of them could go simultaneously, right? But if we had applied some other strategy here, for example, as Solana, we would have calculated all the state dependencies. We would have found that, okay, after doing all this calculation, all of them are independent. Let's run them independently. And then Ethereum would have been the worst in all of this because we would have just run all of these independent transactions one after the other, and that would have been a pain, right? And if any of you folks know about like roll-ups and stuff, that's the strategy that we came up with there as well, like optimistic roll-ups, right? So a lot of these things can basically be extended to normal things that we are doing in mathematics, normal things that we are doing in problem solving. Okay, but that also brings to another interesting thing that I would want to share with you, because while we are studying about Aptos and how great Aptos is, we also need to highlight that what can be the worst case here. What if none of the transactions are dependent? What happens then, right? Like, sorry, independent. What happens then? What if all of the transactions are dependent? In that case, as far as I've read, I'm not completely sure about whether this would be a tested this thing as well. But in terms of whatever articles and research the Aptos team has basically shared, there is actually a little overhead, meaning that it would actually take a little bit more longer as compared to Ethereum for doing the same process, because we're going to try to do all of the transactions at once. Then we're going to realize that, oh no, this wasn't right, and then we try to retry and do those transactions again, right? And that is going to end up us having even a little slight overhead over what would have been the situation with Solana Ethereum in that case. So again, this is also something that I want to mention because I want you to think of this problem not from like just like a very one this thing perspective, but from a more rounded perspective of how this thing works. Okay, yeah, you feel free to ask any questions.
Sneha, so I still have a question. My question is, okay, given the example that you have provided, okay, suppose after the first transaction, okay, my latest version shows 800, right? But
Okay.
my transaction 2 uh, will fail in such a case because the
Yes.
ledgers are not matching,
Yes.
right? Uh, but what if I still have the balance for the transaction 2? Will it still fail?
What if I have the balance for transaction two? What's the question?
So suppose, like you said, you have originally 1,000, and your first after your first transaction, is it 800?
Yes, it's 800.
Okay, I thought it was 200, and then after transaction of one, you got 800. Like when you deducted transaction one from your original balance.
Let me explain. I'm not sure I get the question, but basically, I'm buying chocolates for 200. So
Yeah,
after transaction one, I have 800 balance.
yeah, yes, exactly. Okay, you still
Right.
have 800 in your balance, but your transaction two is you're buying. Wait, I just need to scroll this. So you're buying something.
500
Yeah, for
pizza.
500, but you still have 800 in your ledger. So
Hmm.
in this case, also the transaction is failed because you still
Yes.
have the amount that will go out, which is like smaller than the amount that is present.
Okay, let me again reiterate this thing. So what we're doing here is simultaneous transaction, parallel execution. So for both transaction 1 and transaction 2, at this point of time, both the balance is 1000. And after these like come through, executed, then it will become 800 and 500 respectively. 1000 minus 200, 1000 minus 500. Because at this, it's not like it's not like tx1 has gone through and then tx2 is going. No, it's going to run simultaneously, which means for both of them at that point of time, transaction is the this thing is going to be balance is going to be 1000. So it is not, we are not getting into whether it's sufficient balance or insufficient balance. That's not the problem that we are trying to solve. What we are trying to understand is whether there is double spending here. So if both of these transactions are running simultaneously, there is an error because we are assuming that we have 1000 for both the cases, but it's not possible, right? It's not possible to spend uh, like 1000 on two things, because actually the balance should be 300, 1000 minus 200 minus 500. But if we run these transactions in a parallel manner, then what we are assuming is that at one case it's 800, at another case it's 500. We are still transacting from that 1000. Does this make sense?
Yes. Thank you.
Okay. Cool. Where were we? Aptos is very optimistic. Yes, Aptos is very optimistic. That's true. Okay. So now we covered a little bit around the Aptos block STM, how it's like doing the transactions. Right. One thing I did want to talk about, which is basically mentioned in this slide, is that uh, this one last thing, because before I forget, right? So all of these transactions then finally are going to be grouped into a block, because now, as I mentioned, we are not doing this one by one sequentially. This is not actually committed. This is all going to this version thing, right? So now, instead of how it works with other Ethereum, Solana, and all of this, we are now have all of the transactions ready and they are like committed onto the block, uh, which which can give us a 20x increase in computation speed compared to Ethereum. And as mentioned, there is no upfront knowledge required. Unlike Solana and other parallel execution engines, it can manage the dependencies on the fly. We don't need to know the state beforehand. I think this is a good this thing I put. Yes, this one. This explain me Aptos and stuff, you need to talk to them about this diagram, because what we have here is number one, we have this Ethereum system, and Solana Aptos, we have 4 cars, and we have in Ethereum a single lane. In Solana, we have 4 lanes. In Aptos, also, we have 4 lanes. Now with Ethereum, all of these cars are driving, but what is how they are driving? They're driving one after the other in a sequential manner. So it's going to be obviously slow. If you look at Solana, all of these cars are driving in different lanes. That is good, but these cars have to be assigned a lane beforehand. That hey, let's say it's a Bugatti, you can only drive in lane one. And let's say we have a Maruti or something, and you can only drive in lane four. Uh, Sorry for this discrimination against cars, but yeah, that's like a differentiator. But with Aptos, there is like no like ruling over that. Okay, this car needs to drive in this particular lane. And if you folks did not get the context, the lanes are basically the different parallel execution channels here that they are like going through, and the cars are basically transactions here. Okay, now for Aptos, it means that you do not need to tell the cars that hey, you belong here or you belong there. There is no discrimination involved here. Everyone is going to be treated optimistically. Everyone can basically decide to run on whatever lane they want to. And in case they see that okay, there are certain problems or something, then they can move lanes. They can move lanes. It's essentially what we are talking about. That if there are certain problems, we can manage it on the fly. Whenever it will happen, we'll take care of it. So this is the way that ideally also if you compare with like a road situation where you're in and you're driving and stuff, it makes the most sense for having something like Aptos, right? Um, Not that I'm advocating switching lanes a lot, but yeah, if that makes sense. So okay, are things clear up to this point, up to Aptos block STM? I think, Pavan, that it's going to be recorded and it's going to be published under YouTube for Web3Learn. So yeah. Okay, cool. Uh, okay, okay, cool. Just checking back again. Is this clear up till this point for all of the folks? Okay, perfect. Okay, so now we'll move to part three of this whole equation. So we spoke a little bit around the Aptos BFT. We spoke a little bit around the Aptos block STM, that is the parallel execution engine. Now we'll talk about the language that we're going to work on for the rest of this course, which is Move language. And we're going to see how Move language is differentiating from the current languages and why it's whatever we claim it is. Okay. Uh, um, okay. So Move is basically a resource-based language instead of a transaction-based language. I'm just gonna read through this part and then I can start explaining a little bit. So for recording a transaction, you have to make sure the parties exist and the transaction is not in conflict with other transactions, like in the double spend problem. Instead of recording lines of A to B transactions, Move records the object or resource changing hands and updates the attributes. Okay, I'm just gonna see what's the next slide. Okay, this is a good sketch. Okay, coming back here. Okay, what does a resource-based language means over the okay, Omkar wants me to explain the mismatch thing. So I'm just going to take 1 minute and just explain that, and then we can come back to this. Okay. So let me just copy this. Okay. Okay, Omkar. So what we're going to talk about is we have this two channels. We have two transactions which are dependent in nature, TX1 and TX2. In one transaction, I'm spending 200. In another transaction, I'm spending 500. Both of these transactions, again, assuming that they are independent, we are going to run them parallelly. So now, for both of them, this original state is going to be the truth. They're both going to think that, okay, the balance is 1000. So this will run 800, this will run 500. Okay, balance. Now, this transaction is not actually committed. It's not committed. We are just maintaining a version table. So in this version table, now we have an entry original 1000, tx1 dash, that is the balance after transaction 1, which is 800, tx2 dash, which is the balance after transaction 2, which is going to be 500. Okay. Now, right. Now what happens is that this table will go for verification. Okay. Um, Verification is to basically identify whether the transactions were independent in nature or not. Like this is more or less, or whether there is some double spending here or not. Okay. So during verification, what we'll do is we will compare the state of a particular transaction and before processing, what was the state right before that versus the state which is the latest in the table. So if you see for transaction 1, which is the latest state in the table, original, correct? It's just the one higher, up, just up. Okay, one up. And for transaction 1, what is the state before processing? What was the balance then? Also 1000. So this 1000 and this 1000, they are matching. Numbers are matching. This is correct. Transaction 2, What's the state that it assumed before processing? 1000. But what's the latest state here? It's not original, it's tx1 dash. But tx1 dash has the value 800. 1000 and 800. Not matching. It's a mismatch. So fail this transaction. Does this make sense? Omkar? Okay. Now coming back to our Moblang stuff, right? Like what is Moblang? Okay. So we are talking about a resource-based system. Okay. So what is a resource-based system? So again, I want to make this a bit more interactive for you folks. So I wanted to think back to what is again the concept of digital cash or digital money and how we came up with this concept. Okay, just give me a second. Okay, so when we're talking about digital cash, there's certain properties of money. Okay, so what are the properties of money? Um, you can say that money needs to be durable, right? It should not be something that can be like very easily like this thing, which is why if you see the quality of paper of our notes as well, they use very good quality paper for making that. Okay. Um, Money needs to basically be portable. You can carry money from one place to another, right? But also, more importantly, money needs to be scarce. Money needs to have limited supply. If money is not like limited in nature, then money won't have any value. Correct. And that's like certain properties of money. Like other properties can also be uh, around, like it needs to be acceptable to people. Like some people might say that, oh, for me, uh, I feel like perfumes are like money. That is acceptable to me, but it might not be acceptable to someone else. And that's like what happens when you travel to foreign countries. They don't accept your currency. You can't be like, hey, I have let's say 100 USD, you take it or something. And they will be like, I don't know what this is. I don't know what this money is, right? I don't want to accept it. So maybe USD might not have been the best example, but you understand some very not that famous currency if that is to be exchanged, right? So because of all of these properties of money, we need to treat money as an asset, right? It needs to be defined as an asset. But what happens when we're talking about programming languages is that how do we define something as an asset in a programming language, right? So in Solidity, what ends up happening is that we are defining money as a number, but not as an asset. And that is a problem. Why is that a problem? Because then we are prone to all of the things happening with in Solidity around money that ideally should not happen when we are talking about something like as I said, like the different properties, like limited supply, like double spending, right? So why is this double spending problem so prominent and like difficult to solve, right? It's because we are not saying that money is like an actual currency note. How can you programmatically define something as you have 100 note and then you give that to someone, uh, and then you cannot give it to someone else, right? That's the challenge. And what happens with Solidity is that we are saying that money is 100. There are two different accounts. 100 minus 10 is 90, and the other person goes from 0 to 10. That's the thing, right? uh, but how do we go beyond this? And this is how the double spend problem, this is how the draining of accounts, like wallet addresses, all of these things are happening because the concept is just limited to that. But if we have to define money, there are a couple of things that we can do programmatically, and that is what Moblang came up with. It came up with the concept of resources, that rather than like resources is how we can save money as an asset, as a that defining the object here as an object and not just as a number. And with this concept of keeping money as like an object, uh, like with it came like two main properties, that money, like resources cannot be duplicated or dropped, which is correct. What does this duplication mean here? This is the double spend thing that we're talking about, that money cannot be duplicated. If at the very programming level we are able to capture that money cannot be duplicated, or without anything it cannot just vanish out of existence as well, we are recording all of these things and we are making the system or resource, defining resource in a way that such a thing would be prevented from happening. So this is what move land brought into picture, that instead of having money as just a number, and how we are doing in solidity, what are the operations that you run in within balance for solidity, because you folks are developing smart contracts. It's like simple plus minus, addition, subtraction. And I don't need to tell you, because a lot of you people would have graduated from CS and all. You would have seen things like overflow, underflow, all of these different problems, right? Why do these problems happen? Because we are inherently imagining a different thing in mind, that okay, these are certain things and they have certain properties, but we are not able to carry those properties back into our code, which is why something like this plus minus negative, all of these things happen, which should not exist. And that's why we need to think of it from a perspective of this is money, and it needs to carry with it that those properties, and why we have defined resources which cannot be duplicated or dropped unless explicitly specified, which can be done for certain cases. Okay, so now that we have a good understanding of resources, I want to talk about what is transaction based stuff and what is a resource based stuff. So I want to really take just this example. So when we are doing a transaction in Solidity, first of all, what are the different things that we are doing? We need to first check, like let's say there is, I have my account Sneha, and let's say I want to transfer $100 to Alice. Okay, what does this mean? This basically means that both of our accounts need to be there, right? And it also means that our transaction should not be in conflict with other transactions. The same example, the chocolate and pizza example and all of this. I can't give $100 to Alice and Omkar, right? If I only have $100, that's the case, right? So we are then going ahead and then checking for all of these things as well, like what is happening and all of that, right? So the structure is basically that we are recording a transaction from A to B, right? That this is 100, this is 0 and 100. This is how the flow is looking. But instead of this, move is actually recording the object or resource changing hand, and just is updating the attributes. So what does this mean? What does this look like? It looks like this. So if you see for EVM Solidity, the transaction based thing would look like, if I have NFT, it's moving from A to B. But here, if you're talking about a resource based system, it just has an attribute. So every object here, every token is like treated in this manner, where instead of doing this sort of a table and maintaining it like this, we are maintaining it in this manner, where um, we have our object NFT, which is a token, which is an asset class, which is not just a number that is like, okay, this is going from this to this, but instead uh, this is a resource class which has its owner, and now previous owner was A, now the new owner is B. This is just how we are moving away from that concept of how things are happening, and how move is actually trying to build things in a much more safer manner when compared to EVM Solidity and how we are writing things there. And as mentioned before, Move is like a more evolved version for like Rust. So I'm just gonna see. Okay. So just gonna talk a little bit more around these concepts. I will again be covering these concepts when we start actually writing code in Move. Um, but let's just talk a little bit around what's resources and how we are doing it, because I gave you this previous example which might have been something like, okay, I understand, but I'm not able to actually visualize like what is happening. So let's actually break it down programmatically as well. So resources are actually just structs. So anyone wants to define what is a struct? Can anyone tell what is a struct? Okay, struct is a type of user-defined data type.
It is just like an object with different data types.
Okay, okay, perfect. Right, perfect. Okay. Why are there people who are saying no when I'm asking if someone can define struct? Is it something like I don't want to define it, or it's like we don't need to talk about this and let's just like start moving faster or something? It's a composite data type that groups together. Yes. Okay. Okay, perfect. So again, coming back to our previous thing that we discussed around, we need to move away from, yeah, we need to move away from our definition of like how we see tokens and NFTs as just numbers to this definition of having it as an object. So resources are actually just structs, but what is special about them over structs in Solidity is that these structures have different abilities. They have certain abilities that are defined: copy, drop, store, and key. Again, I will talk about a lot of these things again in detail for the next class, but just going through the basics here. So resources are special structs if they cannot be copied and they cannot be dropped. The same thing that we discussed, like there's like no duplication, and if it's there, like it cannot just magically vanish out of the system also. And because now we are thinking about the struct, it can basically compare back to our previous example that we just saw, that all of these are just like objects where you just need to just like update the attributes instead of doing the transactions from a to b line sort of a format. uh, okay, so we did speak a little bit around, I'm just messing with you, Amrish. Just wanted to check in, like that's it. Okay, so coming to the scarcity and the access control part. Okay, so again, only those four structs are there in Move. What are others? Okay, I think there's been some sort of a misunderstanding here. So I'm not talking about the four things that I mentioned as structs. I'll just go back to the previous slide. Okay, I'm trying to say that all of these structs have like these four abilities. You can define as many structs as you want, but each of these structs have different abilities. You can think of it like a character in a game. I'm just giving you an example. Think about a character in a game, and I can say that this character can fly, it can dance, and it can DJ, let's say. So that's what I'm trying to say, that this character has the abilities to dance, fly, or DJ. And in this example, it would be like the struct has the capability to, uh, yeah, like copy, drop, store, and key. And by default, like whenever we are talking about resources, there are special forms of struct which cannot be copied, or they cannot be dropped. Which is like resources are basically the special ones which are used for our tokens and our assets in Move. Does that make sense? I am not exactly sure, Harsh, as to what core Move looks like. But I don't know, like let's do like a quick search as well. I think there is, so for other folks who want to know what is Harsh's question, it's basically that Aptos, because Move came from this common team of Facebook, right? And then Aptos and Sui came out of it. So there is an open source version of Move, and then there are again two different like versions. One by Aptos team, like Aptos has made their own like modifications over it, and then Sui has also made a couple of their own modifications over it. So yeah, so that's why like there might be differences in terms of how it's shaped up. Uh, I am also gonna actually drop this link. Yeah, I can see it. It's there. Okay. I'm just dropping the link to the Move book, folks. This is the open source book. And as you can see, it mentions in the first page, Move is a safe and reliable language originally created by DM. Okay, now coming back to our this thing. Yeah. Okay. So next slide. Okay. Um, Okay, so Move has these two things that we are going to touch upon. So we touched a little bit about the scarcity part already, right? We talked about money having limited value, and then scarcity is enforced by default because we just discussed that structs that we have resources which are special types of structs which cannot be copied or duplicated. So in this manner, we are ensuring that just like how every note has a particular like serial number or something, and it cannot be like copied, right? It's like that fundamental thing that we are doing here. Okay, and then access control. This again is also a very interesting aspect of Move. I do want to touch a little bit upon it, but I am afraid that I might not have the best understanding of this right now. But Move ensures that only public model functions may be accessed by other modules. Signer here has the highest level of permission and is the only entity capable of adding resources in an account. So I'll just simplify this. What this means by this is that like Move has access control inbuilt within the this thing. So whenever we are talking about any sort of like account and the resources, etc. First of all, we have the signer, which is like the highest level of permission. Uh, yeah, Swapnil. I'll share these slides. Yeah, so we have this access control, which is like, sorry, we have the signer like for any transaction, which has the highest level of permission. And obviously, we have public model functions which are allowed to be accessed by other modules, just like um, how you see like normal CS based stuff that we do, that we have different scopes. And for public functions, they are usually like allowed to be accessed by other classes as well, right? But when we are talking about things that we want to like limit access to, then in this case we're talking about the signer having the highest level of permission, and the signer can basically also delegate certain permission levels to other folks as well to access different things. And again, these are concepts which are not very easy to be built in Solidity. Like this, for these kind of things, you would have to build different modifiers, build like have different modifiers with different like permission sets. And it's not something that you can be like 100% sure that, you know, like if certain hacker wants to hack it, they can possibly like try to find a way. But this is something that is different because the concept of access control is baked into the system. And another thing I do want to mention here also is, yeah, as far as I remember, so with MoveLang, because of these access control things built into the picture, have how many of you folks have any sort of like Solana like wallets like Phantom, etc.? Okay, 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 cool. So has this ever happened to you folks that someone sends you some spam NFTs like having no real value and for some spam stuff? And yeah, right. So ideally this should not be something that should be allowed, right? So anyone who knows your wallet address can basically like spam you, send you a lot of like unwanted things, right? How do you like deal with a problem like this, right? So in and here we are also talking about like if you see spam filtering in terms of like how it works in email and all, we have NLP through Google and stuff that will just flag it, okay, this sounds like spammy, let's put it in promotions or something. or it will have something like that, hey, the domain from which this is coming, this domain authority is not that great, so let's put this in spam, right? But we don't have such an infrastructure when we're talking about communication between wallets. Like, people can send whatever they want to send, and you are going to have to deal with it. But that's not the case for Move, because in Move, if there is a particular like token contract and they want to send something to you, they cannot do it unless you grant them the permission that, hey, this particular contact address is whitelisted and it can send me something. And that is like the beauty of Move, and how it's developed, because they're actually thinking uh, like away from just having a concept of like how we just have an account, we just have token, it's just a number. It is moving away from the concept to actually think that, hey, if we do have an account, how do we, like, deal with like some unwanted stuff coming in? How do we make sure that, okay, we are not how can we think of it from an actual perspective of having like a digital cash, and how that would look like, the entire process. And one interesting thing that I want to mention here is like the one of the initial like places from where Bitcoin came into actual existence was from, I think it was Hashcase. I'm not exactly sure. It was some guy named Adam, and he had basically come up with this scheme of like this protocol of like filtering out spam. And this is very interesting for people also. Like, I personally found it very interesting, because proof of work started from this concept that, hey, there needs to be some work to ensure that people are not lying together in a decentralized system, right? And it was similar to getting spams in mails, in the sense that in those days we did not have NLP, we did not have Google filtering and all of that. So how can you encounter, like, how can you deal with this particular problem of like spam filtering? So he had basically done this thing where, let's say, Alice wants to send an email to Bob. What happens is that Alice will send the email, but Bob's system will respond back with like a very not like a very difficult problem like Bitcoin, but like a but like a problem, like a human solvable problem, mathematical problem that will be sent back to Alice. And if Alice can solve that problem is only when the mail gets sent to Bob. And this again is a very interesting, because that means that Alice is rate limited right now. Every time, like, let's say Alice is a spammer, Alice cannot send 1,000 emails, like, all the time, because in order for the X person to receive that email, Alice needs to stop time and like solve the problem, and then that gets sent. Yes. uh Kondapakka has given the reference. I'm so sorry if I mispronounce your name. Manishan. Okay. Manishan has given the reference uh, on the same. You can look into it. But that's how basically that idea of like, okay, this is how we can solve for this. Like, this is how we can make sure that the malicious efforts and all of this is not in the system, because everyone here is trying to solve this extremely difficult problem. And this is how like the whole concept of, again, Bitcoin came into picture. Okay, now coming back to the actual class stuff. Okay, so as I said, with this access control, you can decide and define that if I don't want to receive NFT from somewhere unsolicited, like thing that they are sending me, you can choose to do that, because you will be the one who will be granting permissions to certain contract addresses to send you stuff. Okay, so this is again how Move kind of differentiate away. I think that is, yeah, I think that's the end of the slides. Okay, any questions? Or are things clear up to this point? For the next class, and this would be good if you folks can set this up, I'm just gonna write like 2 wallets that I want you to set up on your system. One is Petra wallet and the next is Martian wallet. Okay, one second. I'm gonna also try to find the link to this. Petra wallet is a wallet that has been developed by the Aptos team. Martian wallet I don't know who are the creators, but yeah, I'm just sending you the links. So next class we will actually start working on Move because we have discussed a little bit around what is Aptos, history of Aptos, why is Aptos like, uh, like talking about all this throughput and all of this, like how are they differentiating from the other blockchains, right? And next class will basically start with Move. We'll start with setting up the environment for Move. I think there is a browser-based environment as well. I'll see if that is working fine and if we can develop on that, like the initial contract and stuff. But yeah, it's gonna be pretty hands-on from the next class forward. So mm, just give me a second. I'm just copying the um, Martian wallet link. Mm, mm, okay. Yeah, Quantum is also pretty great. You can install that as well. Fine with anything. This is like the top two that I could think of, so I just sent that. Quantum has actually like very good team as well. So okay, great, perfect. Another thing that I wanted to mention before we wrap this up. Okay, this is I'm just gonna take like 2-3 minutes to talk about a little bit about what I do as well. I did not take the time at the beginning. So, okay, so hi, I'm Sneha. As Kiran also mentioned, I'm the founder at Social 3, where we are building a Web3 professional network. We have currently over 400 job opportunities on there with over 110 companies, Web3 jobs, Web3 internships. So, yeah, if that is of interest to you, then definitely check it out. And because we are going to have this relationship of being student and wouldn't call myself like a teacher, but like a mentor maybe. So yeah, a student or a mentor sort of relationship. So would really appreciate if you can check out what we are building, sign up, give me feedback, apply for opportunities. If all of like if any of you are like looking for opportunities in front end, back end, full stack, and all. I'll also share like my links as well, Twitter and all. You can connect with me there, and you can also message me that hey, I'm like I want to apply for this opportunity, and if your profile is good, I'll also personally take it up with the recruiters as well. I am just sharing the link to that. Also noting for you folks that would really want to check in, like all of you folks are on Twitter, right? Because if you are not on Twitter and if you're in crypto and learning and a developer, you need to be on Twitter. So people who are not on Twitter, go like after this class, do install Twitter and like follow a couple of good Twitter Web3 educator accounts. I will share the same as well. Okay, 1 second. Just giving all the links here. So these are my handles. Yeah, Manishan, that is quite sad. We have uh, been following up with companies a lot. To be honest, the market conditions are not the best right now. So there are a lot of companies who said that they are hiring, but are not hiring anymore. And there are a lot of layoffs, etc., that are happening as well. For example, like yeah, I don't want to name anyone right now, but yeah, a couple of companies have laid off in the last week, and a few companies have got shut down in the last week itself. So yeah, there are a lot of companies like that are on there. And then there are a lot of companies where the recruiters have just not evaluated the profile. So we consistently have our Telegram groups with them and we ask them to check the applicants. But yeah, it is a slow process, but we are like trying from our end as much as we can.